Ear infections. A new vaccine was recently tested to see if it could prevent the painful and recurrent ear infections that many infants suffer from. The Lancet, a medical journal, reported a study in which babies about a year old were randomly divided into two groups. One group received vaccinations, the other did not. During the following year, only 333 of 2455 vaccinated children had ear infections compared to 499 of 2452 unvaccinated children in the control group. So we have group 1 and group 2. This is the vaccine group, and this is the control or non-vaccine group. And in group 1, 333 of 2455 had ear infections. And in group 2, 499 of 2452 had ear infections. Are the conditions for inference satisfied? So, independent, random, 10%, success failure, independent groups. Okay, so it says right in the problem that the children were randomly divided into two groups, so that applies. The children, it makes sense that they're independent, being that if one child has an ear infection, it should not affect any of the other children that were randomly divided into these groups. 2455 is not going to be too many, so we're not oversampling 10%. And 2452 is not too many, so we're not oversampling. Success failure, we have 333 kids with ear infections, which means we have over 2,000 who don't. So that group 1 meets our success failure criteria, and so does group 2. We have about 500 kids who have ear infections and almost 2,000 who do not. In independent groups, what happens to one group should not affect what happens to the other group, so that condition is also met. B asks us to find a 95% confidence interval for the difference in ear infections. So 95% confidence interval for the difference. So in this case, we are centered at P1 hat minus P2 hat, and then our confidence interval goes out Z star plus or minus Z star multiplied by P1 hat, Q1 hat, divided by N1, plus P2 hat, Q2 hat, divided by N2. So P1 hat is a proportion in group 1, which is going to be 333 divided by 2455. So that's going to be 0.136, and P2 hat is going to be 499 divided by 2452. 499 divided by 2452. That's 0.204. Okay, rounding up. So we have 0.136 minus 0.204 plus or minus Z star is going to be 1.96 times this thing is going to be 0.136. 1 minus 0.136 is 0.864 divided by the size of group 1, 2455, plus 0.204 times 1 minus 0.204, which is 0.796, divided by the size of group 2. So continuing this out, we have 0.136 minus 0.204. That gives me negative 0.068 plus or minus 1.96 times this entire thing. 2455 plus 0.3. the square root of that. So I get 1.96 times 0.011. Okay, 0.011 times 1.96, 0.02. So I get, this gives me negative 0.068 plus or minus 0.02022. So depending on how you rounded, your interval might be just ever so slightly different from mine, but should not make as much of a huge difference. So on the lower end I get negative 0.090, and on the upper end I get negative 0.046. So my confidence interval, my 95% confidence interval, goes from negative 0.09 to negative 0.046. So I am 95% confidence interval confident that the proportion of vaccinated children who get ear infections is between 4.6% and 9% lower than children without the vaccine. And the last part, use your confidence interval to explain whether you think the vaccine is effective. So 0 is not in the interval, so I believe the vaccine is effective. Okay, because I'm 95% confident that the proportion for the students or the children with the with the vaccine, that proportion is lower than the group without the vaccine.